Jez, welcome this time.
Thank you very much.
Hi.
Thanks for having me.
I saw something on one of your videos, and is the reason when you started with continuous delivery your laziness?
That's right. What motivated Dave and me to write the book, I think, was we didn't want to go in at weekends and do releases anymore. We wanted to be able to stay in bed and go to the pub at weekends, and that was one of the key motivating factors behind continuous delivery. Be able to do releases during normal business hours, make them be boring push-button affairs, so that we could have the excitement of actually delivering features.
Cool. Very cool. I'm lazy as well, so I can relate to that. And you mentioned, well, deploying has to be very boring.
That's right. I think the big problem with releases is all the tension and anxiety. That's not really good for people. I think the ideal is that you should be able to focus on your work and delivering the features and happy customers and not have the actual act of putting the release out be the exciting bit, but the value that it delivers.
Super. The floor is yours. Jez Humble.
Thanks. Okay, good morning, everyone. It's my pleasure to be here in sunny Utrecht. And I'm going to talk today about leading a DevOps transformation. So I'm going to cover a few things. Firstly, explain why DevOps and CD matters. I'm going to talk about how DevOps helps with the problems that I'm going to talk about. And then I'm going to spend most of the presentation talking about what DevOps isn't and what DevOps is. And finally, I'm going to end with how to get there and the journey that we're all going to go on. So I prepared a diagram showing the enterprise. So over on the left, we have the golf playing class. In the middle, we have the people who do the work of making things. And then on the right, we have the people who have the job of operating stuff in production. Martin Fowler assures me that that diagram on the top right is valid UML for the big ball of mud that you have in production. And this isn't too bad. We don't have outsourced testing or distributed teams or anything like that. We do have a machine that goes bing to tell you that everything's working. This is your monitoring. So what happens when we press play on this diagram? Well, some executive comes back from a particularly fine round of golf with an idea for an exciting new product that we're going to build. And after many months of analysis and estimation and budgeting and planning, eventually an enormous project plan lands on some poor project manager's desk, and they begin the work, months or maybe even years of building this project, after which it gets tossed over the wall into operations. We wire it up, bing, it works, yay, and then the team that built that thing disappears and goes off and does something completely different, and the thing they built lives forever in production, never to be retired. Well, there's many problems with this model, not least of which is the fact it takes so long to get anything done. So this is why we have Agile. And the idea of Agile is, well, maybe we can go a bit faster. So what happens is, the Agile transformation is inflicted, first of all, on the engineering department. Everyone goes to the 2-day Scrum training, and now we're taking orders from management standing up instead of sitting down. And that huge backlog of work that we can't ever complete is now prioritized and estimated, and now we're Agile, yay! How do we think the rest of the organization reacts to the exciting news of the Agile transformation? Are they filled with joy and happiness at the brave new world? Well, often not the case. The whole point of Agile is better collaboration between engineering and business. That's problematic for the business because it means less playing golf and more talking to the engineers. That means visiting the engineers. Often there's not any windows or nice art on the walls. The decor isn't as good. And then the engineers aren't very keen on it either because, the whole reason people become engineers is so you don't have to talk to other people. So now we have to talk to the business. That's pretty awkward. How does operations feel about it? Who in this room works in operations, infrastructure, that side of things? Anyone? Okay, a few of you. Quite a lot of you. Wow, that's great. Awesome. So we did the DevOps. Great. So IT operations, instead of getting some nasty ball of mud tossed over the wall once a year. Now we're getting new stuff tossed over the wall all the time. And that's terrible. My goodness, stop the madness, please. So IT operations is like, please, this is terrible. And engineering is saying, what do you mean? We're doing TDD, we're doing XP, we have nice loosely coupled components. What are you talking about? And IT operations says, well, that's lovely for you. It's a shame it doesn't actually work in production. And it's important to bear in mind, IT operations has a natural and logical reaction to this new world where they're getting all this stuff coming at them. And the reaction is to create a barrier which is called the change management process. And the job of the change management process is to make sure that nothing ever changes. So this is where we find ourselves in many organizations. Anyone here have a friend who maybe has had this experience? Okay. All right. So this is a common experience for many agile organizations, or organizations that want to adopt agile, and DevOps is designed to help with this problem. So the way I think about DevOps, lots of people want a definition. There's no definition. That should not make you sad. I think it's important to think about DevOps in a historical context. Why did DevOps happen? What were the factors behind it? And I think of the movement of DevOps as a community of people who had to solve a problem that had never been solved before. How do we build large-scale, distributed, reliable, secure systems and be able to keep making changes to them while keeping them secure and reliable? That's a hard problem. We haven't solved it yet. We're still solving it, and we still have new tools all the time which help us solve that, but we're not there yet. I've spent the last 5 years now, studying high-performing organizations and DevOps with a team, including Dr. Nicole Forsgren and Gene Kim and Puppet Labs. And we have a lot of data that we've gathered over the years to investigate DevOps and what works and what doesn't. One of our first findings is that software delivery actually makes a difference to your business. We've been told for so long that IT doesn't matter, and our data shows that that's not true. Firms with high-performing IT were twice as likely to exceed their commercial goals in terms of profitability, market share, and productivity. So high-performing IT makes a difference to your organization's bottom line. Last year, we also looked at non-commercial goals. We found that high-performing organizations were also more than twice as likely to exceed mission-related goals and customer-related goals like quality, operating efficiency, customer satisfaction, achieving mission goals. So this stuff matters. How well and how fast and how cheaply you can deliver software makes a difference. The second question is, how do we measure performance? Well, we found a statistically valid way to measure performance that has worked consistently over the last 4 years we've been gathering data. We use two different kinds of measures. We look at, firstly, a measure of speed or throughput based on, number one, lead time for changes. So lead time for changes is from version control to production. How long does it take you to go from version control to production? Release frequency is how frequently you release, as you might expect. And then we have two stability metrics. When something goes wrong in production, when there's an outage or a service degradation, how long does it take you to restore service? And then finally, change fail rate. When you push a change into production, what percentage of the time do you either have to roll back or emergency fix? The one thing that I want you to take away from today is perhaps a surprising result. High performers do better at both throughput and stability. We're really used to thinking of speed and stability as a trade-off. People say, go fast and break things. Our data shows that that's not the case. High performers are not making a trade-off. What we find is that high performers are able to release on demand multiple times a day. They have lead times of less than an hour. They can restore service in the event of service degradation or failure in less than an hour, and they have a very low change fail rate. Meanwhile, low performers are releasing much less frequently in big batches. Their lead times are much longer because any change gets mixed up with a whole bunch of other project work, and we release that as a big bang release rather than feeding out features continually. It takes longer to restore service when there's an outage, and a significantly higher change fail rate. So high performers are doing better at both throughput and stability. What DevOps gives you is the ability not just to move faster, but also to produce higher quality systems and more stable systems as well. Speed enables stability and quality. It allows you to discover and correct much more quickly. It makes your whole organization more nimble. In terms of the art of the possible, I really like to show this. Sorry, before I move on, I should say, this is true of all different kinds of organizations and all different sizes of organizations. These results hold for financial services, for government, for big enterprises, and for small startups. We find large regulated companies in our high-performing group, or at least parts of them, and we find startups in the low-performing group. So you can do this stuff in any industry, in any size of organization. In terms of the art of the possible, I like to show this slide from Amazon from 2011. Amazon is making changes to their production environment every 11.6 seconds. They're making up to 1,079 deployments in an hour, up on average 10,000 boxes receiving those deployments, and up to 30,000 boxes receiving those deployments. So a few things I want to point out about this. First of all, this was extremely hard for Amazon to achieve. They spent 4 years re-architecting their entire platform from a monolithic system to a service-oriented architecture. That was extremely expensive and hard for them to do. Secondly, Amazon is a highly regulated organization. They're a publicly traded company. That means they have to follow Sarbanes-Oxley. They also process the occasional credit card transaction. That means they have to follow PCI DSS. So they're highly regulated, very large, and yet they're still able to achieve these results. There's nothing really special about Amazon other than they had the consistent pressure and motivation to continue to work to improve. That's really what's different about them. A lot of people, when they think about DevOps, they think about tools or reorgs. I think my main message about leading a DevOps transformation is culture and architecture are the main things you need to focus on. So I hear a lot of myths about DevOps. A lot of people think, well, let's fire our testers and systems administrators and hire DevOps experts. So I want to be very clear, this is not a good idea. You should not do this. Apart from anything else, it's really hard to hire DevOps experts. There aren't many people who already know how to do this, and the people who did do it learned on the job. I learned because I was working in a startup where I had to do everything. I had to wire up racks, and I had to write software and do everything in between. The people who learned how to do this weren't born DevOps experts. They didn't study DevOps at university. They just learned how to do things by solving problems on the job. Adrian Cockcroft, who was the cloud architect at Netflix, now works at Amazon, one of the pioneers of using Amazon at scale. He would go and give talks at big organizations, and they would say, Adrian, it's okay for you at Netflix. You've got all these amazing people. Where do you get them from? And he would turn around to them and say, I get them from you. These people learned because they were solving problems. Anyone in your organization can do that. The trick is, how do you create an organization where people can learn on the job, and they're not boxed in by their role, but they're treated as real people who have the ability to learn and solve problems for your organization? We don't need to fire people and hire new people. We need to create an environment where people can learn and gain the skills they need to solve the problems the organization has at any time, which will in any case change over the years. Every time the environment shifts or the kind of work we're going to do shifts, we can't fire people and hire new people. We have people already. Let's create an environment where they can learn the skills to succeed and make the company successful. A lot of people want to do reorgs. Well, we're going to reorg everything. My experience is that reorgs are hugely disruptive. They take energy out of the organization for months while everybody learns how to be able to do the work they need to do in the new organizational structure. So you take a massive hit in terms of productivity, and then it gradually tends back up over the months as the organization works out how to succeed. And often the end result isn't much better than the original result. So that significantly impairs your ability to A, do the work you're supposed to be doing, but also even learn how to improve. Learning how to improve and change requires a certain amount of stability in your environment. So reorgs are typically a poor way to achieve improved productivity and ways of doing things. A lot of people think, well, DevOps won't work. We have all these mainframe systems and COTS. If we're going to do DevOps, we're going to have to rewrite everything and put it in the public cloud. Now, I think the public cloud is great. I was working in the US federal government for 1 year, and we did a lot of work putting federal government systems into the clouds, and it was very good for us. But the research that we did for the State of DevOps report is, again, very clear. You can do DevOps with mainframe systems. You can do DevOps with COTS. There's no reason you can't use these ideas in existing systems. So it's absolutely possible to start doing DevOps now with the systems and the organization that you already have. And the best time to start that is today. A lot of people want to buy a bunch of DevOps tools. And I have to say, the tools are amazing that we have today. We have really powerful tools. There's many tools that I love, and they're great. But by themselves, they won't solve your problems. The work that me, Dave Farley, the people who contributed to the continuous delivery book, when we were doing continuous delivery in 2005, 2006, we didn't have any of these tools. We were trying to do continuous delivery with tools like WebLogic and Apache and Java, and we did most of it with Bash, just using scripting in Bash. And we were able to achieve really great results with that. The key thing is, how can you solve the problems? And you can solve the problems without amazing tooling, although the tooling really helps, I will say, and it makes it a lot easier. But if you just buy the tools and you don't change the way you work, you're not going to change anything. Finally, a lot of people seem to think that DevOps means giving developers access to prod. I just want to be very clear. That's a terrible idea. In fact, I don't think anyone should have access to prod. I think all deployments to prod should be performed by an automated set of processes which are triggered by push-button activities. The only time anyone should be logging into prod is for diagnosing problems, and you should make it as hard as possible. People should get a one-time password to log in. Their entire interactive session should be logged and emailed to everyone in ops so that we can work out what happened and fix it. Nobody gets access to prod, especially not developers. One thing I will say, I found that having a platform as a service was really powerful. I'm not going to talk about it in this talk, but one of the things we did in the US federal government is built a platform as a service using Amazon and open source Cloud Foundry, a bunch of other tools. And if you're building a cloud, you do have to give developers access to the API to self-service compute resources in the cloud. That's very important. But the actual deployments should be performed through a CI server. So that's what DevOps isn't. What is DevOps? I think the most important thing to learn and the hardest thing to learn is how do we work incrementally, iteratively in small batches for everything we do. Not just for product development, but for architectural change, for organizational change, for culture change. The way we design organizations doesn't help with this. We have annual budgeting cycles. We have executives with short tenures who want to make a big impact. That lends itself to these big, high-prestige projects where we all work incredibly hard for a year or two and then deliver this amazing result and it's splashed over the front page of the newsletter. That's not how lasting change is achieved. Lasting change is achieved through a series of small steps through experimenting and finding a path and learning rapidly with feedback loops. And that requires that we take big problems and turn them into a series of much smaller problems that we solve iteratively and incrementally. That's maybe not as exciting as, a big bang change, but it's much more likely to succeed. So the classic example of this is projects. We tend to work in projects because that's what the budgeting cycle encourages. We have an annual budgeting cycle, or maybe if we're very exciting and trendy, a semi-annual budgeting cycle, and that tends to lead us to batch up work into these big projects. There's a really great white paper called Black Swan Farming, which talks about some work that was done at Maersk Shipping in Denmark. They analyzed their backlog of around 3,000 different features that were waiting to be developed. And they analyzed it in terms of the opportunity cost of not delivering those features. How much was it costing Maersk to not deliver those features every week that they were not delivered? So this is a prioritization technique called cost of delay. And here's what they found. Hidden in the middle of that backlog, batched up in some big project, there was 3 features, and not delivering those features was costing the organization over $2 million a week for each of those features. Now, those features were invisible. They were part of some enormous project plan. But when they went through and saw this, what they realized is, well, we should stop all work except to deliver these 3 features as soon as we possibly can. This statistical distribution is called a Powerlaw Curve, and the people who wrote this paper, and I'll put the slides up later with an attribution so you can find it. Unfortunately, I forgot to put the attribution here. This is Joshua Arnold and Özlem Yüce. The people who did this analysis have analyzed a bunch of other projects. They find this distribution is very typical. Somewhere in all the projects you're working on, in your portfolios, in your organizations, are a very small number of features which are hugely important to your organization, but they're completely invisible. So one of the things that we need to do is get rid of this idea of working in projects. What we should be thinking about is what's the most important thing we can do for our organization, and get rid of all the stuff that's not important and focus the entire organization on very quickly delivering the things that really are important. That requires focus, it requires transparency, it requires very clear prioritization and collaboration between everyone in the organization. Another example of working iteratively and incrementally instead of big bangs is architectural change. So it's very common to see organizations say, well, we have all these very ancient systems running in production, and we've got to change it all. Anyone in the audience maybe has a friend who's running mission-critical systems on hardware that's no longer supported by the hardware vendor? Right. Anyone here going to admit to buying parts for that hardware on eBay? There's some nods in the audience. That's a real thing. Anyone going to admit to running mission-critical systems where you don't have the source code for those systems? Yeah, there's always a few people doing that. And then people say continuous delivery is risky. So the solution to this often is a big re-architecture. Some architect gets hired or VP and they produce this big diagram, and we're going to do the 2-year architectural refresh and change all this stuff. And then you get about 1 year in, and you're like, well, how are we doing? Oh, I think we still have another 2 years. And then you get another 6 months in. How are we doing? No, still probably another 2 years. And at this point, if you're smart, you're thinking of maybe moving somewhere else because that's what the VPs are going to do. And then if it goes really badly, which is unfortunately quite common, a bunch of senior people get fired, we get some new people in, and there's a new 2-year plan for the architectural refresh. So there's a couple of problems I want to point out with this paradigm. One is a lot of these architectural refreshes focus on the exciting new technologies, but not on the outcomes that we're trying to achieve. So our research, again, is very clear about what you should be aiming for with your architecture. We found that people who could answer yes to these questions were much more likely to be able to succeed at continuous delivery and DevOps and achieve high levels of performance. Can my team make large-scale changes to the design of its system without the permission of somebody outside the team or depending on other teams? Can my team complete its work without needing fine-grained communication and coordination with people outside the team? Can my team deploy and release its product or service on demand independently of other services the product or service depends on? So do we have to do these big orchestrated releases over a weekend where you need to follow the steps in a very particular order, make this change to this database, change this service, reconfigure this thing, turn this off, and if you do anything in slightly the wrong order, everything is going to go horribly wrong? Or can teams just push out their service they're working on whenever they want without having to worry about bringing down the rest of the system? Can my team do most of its testing on demand without requiring a complex, integrated test environment that takes days to configure? And finally, can my team perform deployments during normal business hours with negligible downtime? The important thing about these outcomes is you can do this stuff with mainframe systems. Equally, you could buy all the shiniest new technology and use Kubernetes and Docker and all this stuff and not achieve these outcomes. So if you're going to spend the money, make sure you achieve the outcomes. And again, I want to be clear. Docker, Kubernetes, these are really amazing, powerful tools. They're great. But installing the tools is not enough. The point of that is to achieve the outcomes. And if you don't achieve the outcomes, you wasted your money. Instead of doing a big bang refresh, there's another paradigm for architectural change, and that's evolutionary architecture. There's a new book by Neil Ford and Rebecca Parsons, Patrick Kua, about evolutionary architecture. And Martin Fowler has a blog post about a very common pattern for evolutionary architectural change called the Strangler application. So the metaphor for the Strangler comes from nature. Has anybody seen the film Tomb Raider? Okay, me neither. But in Tomb Raider, it's set in Cambodia, in these temples, and what you can see here is, on this temple, there was a tree growing, and then a bird came along, did a poo on the tree, and the poo was a seed. From the seed grew a vine called a strangler fig, and the strangler fig grew around the tree and killed the tree, and at the end, all that was left was the strangler fig. So the idea is you can use this metaphor to think about evolutionary architectural change. So the idea is don't completely rewrite your existing system and then do a big bang replacement. Instead, over time, you can gradually add new services alongside the old services, and those services will still call into your existing monolithic systems, but then over time, you gradually strangle the monolithic application. One crucial thing I want to point out about this and the service-oriented architecture that people often miss is that each service should have its own data schema. So services should not be talking to each other's data schemas. You see this very often, unfortunately, services which are supposedly independent, but they're coupled to the underlying database schema, and then it's not really a service-oriented architecture. So they can all be running in the same underlying database engine, but the schemas have to be independent from each other. That's very important. So there's some rules for doing this effectively. Number one, don't rewrite existing stuff just for the sake of it. Let the new service-oriented design be driven by the new features that you want to build, at least at first. Make it satisfy some business need. Don't rewrite that existing functionality unless it's to simplify it substantially. Make sure, the key goal in architectural change is to get something done fast. And often the really hard work is, how do we make the scope smaller and smaller and smaller until we can get something so small that we can deliver it in a month or two? Thinking about how to solve that problem is often the hardest bit, but it's hugely important. You want to get something out there fast so that you can start learning, working out what works and what doesn't for your organization, because every organization is different. Design for the ability to test and deploy, where teams can run their own tests and deploy their own stuff, rather than depending on complex integrated testing environments or complex orchestrated deployments. You need to move away from that. And I personally have found that building a platform as a service to deploy on alongside these new services and making sure that platform is designed initially just for those services, that's a great way to start working on a platform as a service. A lot of people thinking about building clouds or platform as a service, they want to solve the entire enterprise's problems. And that will just paralyze you and produce something terrible. Focus on solving one problem with your platform, get that done, and then evolve your platform. Incremental change also applies to organizational change. In your organization, there's a wide variety of people. There's the kind of people who love to buy shiny new phones and the latest thing. And there's people in your organization who aren't interested in new technology. They're very grumpy about it. They just want to carry on working the way that they're working now. Everything's fine. You have to respect that. You can't transform your organization all at one go and expect that change to last. When you're thinking about who's going to try out these new ideas, find the people who are excited about it and have the capability to do it, and help them experiment. And they're going to make a lot of mistakes, and that's okay. And then the rest of the organization will learn from those mistakes and learn what works and what doesn't, and you'll have some confidence that the things that have worked are things that we can keep and move to other parts of the organization. People who are in this right-hand side of the curve are very uncomfortable being the first people to try things, and they'll do everything they can to prevent that. And the only thing that will convince them is seeing in your organization other people succeeding with it first. And even then, it will still be hard. When we work in small batches, what we do is we create feedback loops. And it's the feedback loops that allow us to learn. So working in small batches enables feedback loops, and feedback loops are what allow learning. And that's really the crucial thing about product development, about architectural change, about organizational change, is starting to learn quickly so that we can learn as fast as possible and then change what we're doing based on what we learn. That's the core principle of Agile. That's the core principle of creating learning organizations. And that is only possible if you have feedback loops. The classic feedback loop in continuous delivery is the deployment pipeline. How soon can we get feedback on our changes? But the deployment pipeline is just one example of a general pattern, which is creating multiple feedback loops at multiple layers so that we can get fast feedback that's not necessarily comprehensive and course correct quickly, and then also have other feedback loops which are a bit slower but give us more comprehensive feedback. And that general idea applies to everything. Another thing that's crucial is enabling cross-functional collaboration. Dev, ops, test, products all have to work together throughout the delivery lifecycle. These days, I don't talk about automated testing, I talk about continuous testing and continuous InfoSec, building InfoSec, testing, all these things we care about into everybody's daily work. And that requires that we work together. Working together does not require a reorg. It just requires that people communicate. You can achieve that by just taking people from different functional groups and sitting them around the same table for a while. That doesn't require a reorg. You can do that tomorrow. So it's the communication that's important, not who people report to in the organizational structure. I want to spend a bit of time talking about developing a culture of experimentation, because this is really crucial. What we found in our research is that culture is important, it's measurable, and it has a measurable impact on IT performance and organizational performance. We used a model to measure culture from a sociologist called Ron Westrum. So Ron Westrum was studying safety outcomes in healthcare and aviation. These are industries where when things go wrong, people die, so safety is very important. And he found you could predict safety outcomes based on the culture of the organization, whether those organizations are pathological or power-oriented, whether they're bureaucratic and rule-oriented, or whether they're generative and performance or mission-oriented. And there's 6 axes here. Firstly, how effectively do people cooperate throughout the organization? Secondly, how do we deal with people who bring us bad news? Do we shoot people who bring us bad news? Do we ignore people who bring us bad news? Or do we actively train people to bring us bad news so that we can act on it as soon as possible to fix problems before they become catastrophic? How do we deal with risks and responsibilities? Do people avoid responsibility because they know if something goes wrong, they'll be punished? And are responsibilities narrowly defined so that we know who to blame when something goes wrong? Or do we all take risks together because we know that we succeed or fail as a team, not as individuals? How do we deal with bridging between different departments and up and down the organizational hierarchy? Is that encouraged or is it discouraged? Don't talk to the people in ops. We don't want them to know we're doing this. And then finally, how do we deal with failure and how do we deal with novelty? And these 2 things are very tightly connected. If when something goes wrong, somebody gets punished or fired, nobody's going to take risks because nobody wants to be that person. We have to ask ourselves, if something goes wrong and we do an investigation and the result of the investigation is, let's fire Jez, he did something dumb, what about the next person who's hired to replace Jez? If nothing else changes, it's entirely possible Jez can make the same mistake. Maybe if we're serious and we ask ourselves, could I have made that mistake? Often the answer is yes, that could have been me. Anytime you think that it's someone's fault that this happens, ask yourself instead, how could we have got that person better information? How could we have given that person better tools so when they made the decision they did, it didn't have the same catastrophic outcomes? How can we ensure that mistakes have a smaller blast radius? In short, how can we ensure that information flows better throughout the organization so people can make better decisions? And how can we ensure that bad decisions don't lead to catastrophic cascading failures? So the emphasis should be on how do we improve our organization? How do we make our organization more resilient? How do we enable information to flow better through the organization? And that will determine the extent to which novelty is possible. Is novelty implemented? Does it lead to problems? Or is novelty crushed? In an organization where people know that failure is punished, no one will try anything new. Because by definition, something new is risky and it has a high chance of failure. Google did some research a couple of years ago to try and find out how to build a good team at Google. And they looked at a number of different factors, and they thought it was going to be 5 Node developers, 2 Stanford graduates, and fire all the managers. What they found instead was that the number 1 characteristic of high-performing teams at Google was psychological safety. Did the team feel that they could take risks and that they would be supported if things went wrong and that they could be vulnerable in front of each other? We reproduced these results in our research, and we found that the same factors that Google talks about are very important. One example of creating an environment where failure is accepted is to create real failure. Big organizations like Amazon and Google actually do real disaster recovery testing exercises where they actually create real stresses on their infrastructure. At Amazon, Jesse Robbins, who was head of availability, used to perform an exercise where he would power down whole data centers and make sure that the disaster recovery strategy actually worked and that the Amazon systems would continue to work even when the data centers were physically powered off. Google has a whole team that plans out and executes real disaster recovery testing exercises. So they have 1 year, the scenario was aliens invade Silicon Valley. And they turned off the fiber connection between Mountain View and the rest of the world. turned off data centers, and actually caused real impact on the infrastructure. And the teams had to maintain the service level objective. So Kripa Krishnan, the woman who runs this team at Google, wrote an article about this, which I really recommend reading. And she says, for disaster recovery testing events to be successful, an organization first needs to accept system and process failures as a means of learning. We design tests that require engineers from several groups who might not normally work together to interact with each other. That way, should a real large-scale disaster ever strike, these people will already have strong working relationships. So how many of you have actually executed a realistic disaster recovery testing exercise in the last year? Okay, so a few of you, and that's great, but that number should be much higher. A disaster recovery testing scenario that you haven't actually tested is like taking backups without practicing restore. That is to say, it's useless. You have to actually do those things in real life and then learn from them. Another example of learning culture is a company called Etsy, or at least Etsy before they made all the recent changes. So at Etsy, they have a developer conference, and every year they give a 3-armed sweater to the person who causes the biggest production outage in the last year. It's an award. And the reason it's a 3-armed sweater is because the 404 page on Etsy is a picture of the sweater with 3 arms. So this is John Allspaw, who at the time I think was VP Engineering at Etsy, giving the award to Rin Daniels, who'd caused that outage. And Rin blogged about the outage and what happened on her blog, and I really recommend reading it. And they talked about how when the outage occurred, they got on Slack and said, listen, I need help. And the immediate response from everyone around was to ask, what help do you need? And they swarmed on the problem, and they fixed it, and then they had a blameless post-mortem when they investigated the contributing factors and asked, how do we improve the system to prevent this happening again? And then Rin got an award for helping the organization learn how to become more resilient. And another well-known example of this is Netflix. I'm sure everyone's heard of Chaos Monkey and the Simian Army that actually causes damage to their production systems on a regular schedule to prove that those systems are in fact resilient and help engineers learn how to build more resilient systems. Finally, DevOps is about continually working to remove waste and make things better. A lot of it is janitorial work. There's 2 tools that I want to talk about to help you with this. Firstly, value stream mapping. And I actually did a value stream mapping exercise for a large Dutch company with the leaders of all the different departments in the value stream, from product to development, testing, and ops. The hard part of value stream mapping was actually getting all those people in the same room at the same time. And once I did that, we went through how they took releases from products to development to testing to operations to production. And what was crazy was that those senior leaders started arguing. Someone would say, I would ask, well, how does this process work? How long does it take to get work through this process? How much of that time is actually value-add time? How much of that time is just waiting for something that's not value-add? What percentage of the time does the person you're giving that work to send it back because it wasn't done right the first time? These are the 3 metrics that we particularly care about when doing a value stream map. And someone would say, well, this is what happens. And another executive would say, what do you mean? That's not how it works. It works like this. And they would say, no. This is how it really works. And seeing the executives actually reach an understanding about how things work was a very powerful experience. But the hard part was getting them all in the same room at the same time. And then even harder is getting them to think about, where do we want to go now? What do we want to be the case in a year? What do we want to be the case in 1 month? Let's set agreed goals for how these processes should behave 1 month from now. And then we'll meet again in a month and talk about what worked and what didn't, and work out what our goals are for the next month. And the goal bit is important. You don't plan exactly how you're going to do it. You set target conditions, goals, and then your people work out how to solve that problem themselves. That's the very important piece. If you tell people what to do and give them detailed instructions, they won't feel bought into the process. They won't be invested. They won't have skin in the game. You've got to give people goals and let them work out how to do it, and that's how they learn. And when they learn, that's how you create those DevOps engineers that you want. The final thing that I think is useful thinking about how to improve is capabilities. So the main outcome of the last 4 years of research that we've been doing is what are the capabilities that drive organizational performance. And this might be a bit hard to read from the back, so I'm sorry, but these slides will be online. Lean management, limiting work in process. Lean product development, working in small batches, making work visible. Creating teams that are allowed to experiment with new ideas. The software development practices of continuous delivery. All these things impact performance, throughput, and stability. They impact culture. Culture, in turn, impacts performance, both organizational performance and software delivery performance. And they also result in happier teams, less burnout on your teams, more satisfied employees who identify more closely with the company. That, in turn, all depends on transformational leadership. Leaders who have a vision, who intellectually stimulate their employees, who have inspirational communication, who communicate the goals over and over again, who reward people who learn and take risks. Having leadership that's supportive even when there's failures and setbacks. And then recognizing people who've done the right thing. Not the heroes who took crazy risks and pissed off other people, but the people who tried things that didn't work and then helped other people learn those lessons. So I just want to end with a brief overview of the journey. The first and most important thing is to agree and communicate the measurable business goals. I hear a lot of people say, we want to do continuous delivery, we want to do DevOps. And my first question is, why? What are you trying to achieve? What's the measurable business goal you're trying to achieve? Could I go to any employee in your organization, ask them what the measurable goal is that they're trying to achieve, and they would all tell me the same answer? That's step zero. And so many organizations fail on that first and most important step. Are the measurable business goals clear, and are they known to everyone? Because we repeat them over and over again, and we can see them all over the workspace. These are our goals, our measurable goals for the next month. Give teams the resources and the time to experiment. If you want to try something new and your manager says, I'd love to let you do some test automation and some refactoring, but we can't because you've got to do the work. We don't have time. If people can't get time to experiment and resources to experiment, it's not going to happen. And we have to reward learning, which means rewarding people taking risks and failing, not just rewarding people who did what they were told and won the victory for the team. Collaboration is very important, and you can do very simple things to enable this. A lot of organizations have an internal DevOps Day conference, an open space where people from across the organization can run their own sessions and share knowledge. You could even pay for lunches for your staff. The developers hate the auditors. Have the auditors come and give a brown bag lunch to the developers and pay for everyone to get pizza or whatever. Get those people who normally don't talk to each other, maybe don't even like each other because they don't know what the other person does, get them together in a room and get them to talk about things and give them free food. Free food is a powerful motivator. This is a lesson I learned from Linda Rising. And then the key is not how big is the impact we can create, but how quickly can we create an impact and how quickly can we learn and then share what worked and crucially what didn't work. And then finally, and most important, keep going. You will fail, and then you'll fail again, and then you'll fail again. High-performing organizations never give up, and they're never satisfied, and they're always trying to get better. You don't hear, we've always done it this way. This is good enough. That will never work at our organization. People don't treat obstacles as objections. They treat them as challenges. And when they finish solving for one obstacle, they look for the next obstacle, and they keep going. And that's the culture you've got to build in your organization. Thank you very much.
Thank you very much, Jez Humble. Thanks very much. Here we got a robot for you.
Yay!
We don't have the remote control because it's all of wood, and inside there's some wine in it.
Oh, brilliant. It's my favorite.
Thank you very much.
Time for questions?
Yeah, we have time for questions. Who dares? What's the question for Jez Humble? Yeah, over there. Hi, what's your name?
My name is Marieke Verhoef. You said it's not necessary to do a reorganization. Just bring the people together. But I also hear people say, when it's in one department, all the people around one system, so testers, developers, people who do the daily running of the system, it works even better.
Yeah, so that's a great question. Thank you for asking it, because it's an important clarification. I strongly believe that cross-functional teams are way more productive than teams centered around a particular function, like development, testing, or around a particular layer, like, front end or database. So yes, cross-functional teams are very important. It's really critical to create cross-functional teams. And those teams can be centered around services, if you have a service-oriented architecture, or they can be centered around features. But yes, it's very important to have cross-functional teams. My point is, you don't have to reorg to achieve that. You just have to sit those people in the same place. So where that does involve organizational change is where your organization is distributed across multiple geographic locations. Then you have to think about moving people around in order to achieve that. But yeah, I absolutely think that having cross-functional teams is very important. It can also work remote. If you have experienced people, then having people work in remote locations, and we did this in the US federal government. At 18F, we were a remote organization. People would work from home all over the place, but they would still be cross-functional. And the cross-functional bit is very important. I think that's right. The remote thing works really well for experienced teams. It's much, much harder when you have a range of different levels of skill. There, actually having people in the same physical place is much more effective.
Thank you. Answering your question? Yeah, okay.
While we're waiting for the next question, you can get my slides and a bunch of other free stuff by sending an email with the subject DevOps to jezhumble@sendyourslides.com. The slides will go up in about half an hour, but if you send an email, subject DevOps to jezhumble@sendyourslides.com, you get a bunch of excerpts, including my new book, Accelerate, which has a bunch of the research in it by sending an email to that address.
Next question, Jez, for you.
Yep.
Oh, sorry. Hey, hi Jez, I'm Maurice. I just noticed one of your slides said that is your team capable of making a large-scale change without the approval of others and without looking outside your team?
Yeah.
To me, that sounds like a silo which we would like to take away using DevOps. So how should I understand this topic?
Sorry, I missed the second half of your question.
It sounds like a siloed approach.
Right.
Which silos we would like to take away using DevOps. So how should I understand this topic?
Yeah, that's another great question. So in every big organization, you're going to have teams. And the communication bandwidth within the team is going to be much higher than the communication bandwidth between teams. So yeah, inevitably, there's going to be communication bandwidth differences. And the main thing, this is called Conways Law, or it's one of the implications of Conways Law, is to organize your teams such that those low bandwidth intra-team communications are used as efficiently as possible. And that means wherever you have fine-grained decisions to be made, so we're building new features, all the people involved in building, designing, and operating those features, that's going to require fine-grained communication, so those people should all be on the same team. And then communication between teams is going to be lower bandwidth necessarily, and the drop-off is quite steep. Once people are sitting, I think, even more than 20 meters away from each other, the communication bandwidth drops off quite steeply. It's quite a fast effect. There's an architectural technique to manage low bandwidth communication, and it's called APIs, or service layers. So you've got to use software architecture techniques, APIs and service layers, as a way of managing the low bandwidth communication between teams. So I'm not saying that teams shouldn't collaborate. What I'm saying is you have to respect the fact that between teams you have less communication bandwidth than you have between teams. Use that communication bandwidth wisely to communicate higher level goals and progress, not fine-grained decisions about how we implement particular individual bits of work. Does that help?
Okay. One last tiny question. Yeah, got one over there. Hi.
Sorry. How do we get the VPs off the golf course?
How do you get
VPs.
free pizza on the golf course? If I knew, I'd tell you. Sorry. I still haven't solved that problem.
No all in one? No.
Yeah, okay. All in one. There
Thank
you
you
go.
very much. One big round of applause for Jez Humble. Thank you very much.
Thanks very much, everyone.
Thank
Thanks.
you. Yeah. 10:20.